Our lesson for today is all about theorems on angles formed by tangents and secants. Okay, but before we proceed to our lesson, okay, let's have a short recall on a tangent and a secant. So when you're talking about tangent, it is a line that intersect one point on the circle. So here, one example of tangent here is line x, y. So as you can see, it is a line that intersect one point of the circle. So this the tangent is line x, y. So remember the symbol that I've been using because okay, you must be always remember those symbols to be able to indicate that it's a line, it is a line segment. Okay, so next one we have the secant. So when you're talking about secant, it is a line that intersect from point of the circle and it is another and also intersect another point on the circle and it will be extended outside of the circle. So as you can see, line AB is an example of a secant. So we have the secant here is line AB. Can you follow? So remember these two figures or geometric figures because this is very important as the lesson go on. Okay, we have here theorem number 1 for the theorem for segment and tangent. So we have here the theorem number 1. Okay, if a secant intersect in the exterior of a circle, then the measure of the angle formed is one-half the positive difference of measure of the intercepted arc. So let's identify. So as you can see, there are two secant here. We have the line BC and line AD. But they intersect outside. They intersect in the point X, and they form an angle here. They form an angle here. So based on the theorem, if the secant intersect exterior of the circle, so they intersect in exterior, so exterior nasa labas, then the measure of the angle, so the measure of this one, or the angle, is one-half the positive difference of the measure of the intercepted arc. So where is the intercepted arc here? So we have arc AB and CD. So those are the intercepted arcs. So let's have one example here and let's compute what is the measurement of line AXB. Okay, so let's have a given here. So given, so the measurement of line AB or arc AB, I should say, is equal to 40. And the measurement of line CD is equal to 60. What is the measurement of angle AXB? So we have, or let's say this one. Since it's an angle, so let's name it as a whole. So let's say DXC, still that is the angle. Okay, so DXC. So let's have what is the measurement of DXC. So that is the question. That is the missing. Now let's find the measurement of angle DXC. So based on the theorem, so the measurement of the exterior angle of the circle, then the measure of the angle formed is 1/2 positive difference of the measure of the intercepted arc. So since we have, M measurement of the DXC is equal to 1/2 the difference of the arc measurement of arc AB minus measurement of arc CD. Okay, so let us substitute the given value. So we have 1/2. What is AB? We have 40 degrees supposed to be. So it is a, what do you call that, arc. The units for arc is degrees. So this will be 40 degrees minus, what is the measurement of arc CD? We have 60 degrees. So we have 1/2. 40 minus 60, that will be negative what? Negative 20. Since it's talking about positive difference, so therefore it turned to positive. That will be 1/2 multiplied by multiplied by positive 20. Remember, it is state on the positive difference. So therefore, if it's negative, that will be turned to positive. And it remember, that is a measurement. There's no such a negative measurement. So therefore, it will turn to positive. So we have 1/2, sorry, we already this one. So 20 multiplied by 1, that will be 20 divided by 2, that the answer will be 10. So that is now the measurement of angle DXC. Okay, can you follow? Let's have example number 2. Okay, so let's have the theorem number 2. If a secant and tangent intersect in the exterior of a circle, then the measure of angle formed is 1/2 the positive difference of the measure of the intercepted arc. Okay, a while ago we have 2 seconds. Now we have a tangent and a secant here. So based on the theorem, okay, so if a secant and tangent intersect an exterior, so they intersect exterior here, the measurement of the angle formed is 1/2 of the positive difference of the intercepted arc. So we have here the intercepted arc MN and MP or OPM. So that is the intercepted arc. So if we get the difference of the two, then it will multiply to 1/2. That will be the measurement of this angle. Okay, so let's solve. Okay, from the let's have a given. Okay, let's have a given for the, so let's have given. So the measurement of arc MN is equal to 30 degrees. So let's have this is 30 degrees. And the measurement of OPM, measurement of arc OPM is equal to, let's say this will be 120 degrees. Will be 120 degrees. And now what is the measurement of angle MAO? So let's say MNA. Or pwede rin naman OAM. Sorry. That will be, what is the measurement of angle OAM? That is now our problem. So based on the given, so that is based on the theorems, the measurement of the angle form is 1/2 positive difference of the measurement of the intercepted arc. So we have measurement of angle OAM is equal to 1/2 of the intercepted arc, or the difference of the intercepted arc. So we have M measurement of let's say OPM minus the measurement of arc MN. So we have 1/2, then the measurement of OPM is 120 minus the measurement of MN is 30 degrees. Okay, so we have, let's subtract. So we have 120 less 30, that will be what? That will be 90. So that will be 90 degrees. So we have 90 multiplied by 1, that will be 90, divided by 2, that will be, okay, 45. That will be the measurement of angle OAM. Okay, so that is for the secant and tangent intersection. Okay, let's have example number 2 and number 3, or the theorem number 3. So if two tangents intersect in the exterior of a circle, then the measure of angle formed is 1/2 the positive difference of the measure of the intercepted arc. So now, a while ago, we already done with the secant, then secant tangent, now tangent and tangent. So here in the theorem, okay, so we have here in the figure we have two tangent here, they have YQ, tangent YQ and tangent WQ. Okay, so they are two tangent and they intersected outside of the circle. So now what is the measurement of this angle? That is the question. Now how do we get that? Using the theorem, based on the theorem, the measure of the angle formed is 1/2 positive difference of the measure of the intercepted arc. So the intercepted arc here is YW and YXW. So that is the intercepted arc. So let's solve and let's have a values for those intercepted arc. So given, so we have a measurement of WXY. Let's say WXY, measurement of the arc WXY is equal to 150 degrees. And the measurement of YW arc YW is equal to, let's have 30 degrees. Okay, now what is the measurement of angle YQW? YQW. That is the problem. Okay, based on the theorem, let's use the theorem. The angle form, the measure of the angle form is 1/2 the positive difference of the intercepted arc. So the difference of this one and 1/2 that one, measurement of the difference of this intercepted arc, and 1/2 of that will be the measurement of YQW. So let's have measurement of angle YQW is equal to 1/2 multiplied by the difference. We have the measurement of arc x, the WXY minus measurement of YW, arc YW. Okay, let's substitute. We have 1/2. Okay, so we have, what is the measurement WXY? We have 150 degrees minus the measurement of YW is 30 degrees. So we have 1/2 150 minus 30, that will be what? 120 degrees. That will be 120 degrees. So 1/2 of that will be 120 multiplied by 1, that will still 120 divided by 2, so that will be 60 degrees. So that is the measurement of angle YQW. Let's have the theorem number 4. If 2 seconds intersect in the interior, a while ago it is intersecting exterior, now it is interior of the circle, then the measure of the angle is 1/2 the sum of the measure of intercepted arc by the angle and its vertical angle. Okay, so based on the theorem, so let's identify. So as you can see, it is a secant. There are 2 seconds here, and they intersect inside of the circle. So therefore, it is interior of the circle. Now, okay, so as you can see, there are 4 angles that is formed between the intersection of the 2 seconds. Now, what is the measurement of angle 1 and measurement of angle 2? Okay, so using the theorem, okay, so let's identify first let's assign let's have a given first before we, so that it's clear for you. We have given, we have measurement of AB or arc AB is equal to 65. Measurement of DC is equal to 125, and measurement of line AD, arc AD I should say, is equal to 115 degrees. Sorry. Then measurement of line BC, arc BC I should say, is equal to 55 degrees. Okay, so that is the given. Now, what is the measurement of angle 1 and measurement of angle 2? Okay, so using their intercepted arc, so let's have this one. Okay, let's focus first the angle, let's say this one para it's clear. So we have AB is 65 and DC is 125 degrees, and AD is 115, and line BC is 55 degrees. Okay, so let's focus on the uh, line, the angle 1. Okay, so the intercepted arc are we have the line AB and I know arc AB and arc DC. So those are the intercepted arc of angle 1. For the angle 2, the intercepted arc of angle 2 is arc BC and arc AD. Can you follow? Okay, so let's focus on the angle 1. So based on the theorem, one half the sum of the intercepted arc, or yes, intercepted arcs is supposed to be by the angle and its vertical angles. Okay, so we have uh, angle 1, measurement of angle 1 is equal to 1/2, okay, the sum measure. So we have intercepted arc, so we have AB, measurement of arc AB plus measurement of arc DC. So we have 1/2. What is AB? 65 degrees plus 125 degrees. Then 1/2. Sum of that will be what? 190. 65 plus 125, that will be 190 degrees. 1/2 of 190, so that will be what? Okay, so the answer will be 1/2. So we have 190 divided by multiplied by 1 divided by 2, that will be what? 95 degrees. So that is the measurement of angle 1. So if this will be 95, since it's a vertical angle, the measurement of the opposite angle will also 95 degrees. Next one, we have the measurement of angle 2. So still same process. So using the intercepted arc, we will add the intercepted arc, then multiplied by 1/2. So we have 1/2. What is the intercepted arc? So since it is angle 2, BC and AD. So let's have AD, measurement of arc AD plus measurement of arc BC, then it is equal to 1/2. So let us substitute. So we have 115 degrees plus 55 degrees is equal to 1/2. 115 plus 55, that will be 170 degrees. Then let us multiply 170 into 1/2. So we have 170 multiplied by 1 divided by 2, that will be 85. Okay, so that is the measurement of angle 2. So if the measurement of angle 2 is 85 and the measurement 85 and they are vertical, therefore vertical angle, therefore it is also 85 degrees. So if you total this one, that will be the 365 degrees. 360 degrees, I should say. One revolution is 360 degrees. Okay, so that is for the theorem number 4. Let's have the theorem number 5. If a secant and tangent intersect at the point of tangency, then the measure of each angle is 1/2 the measure of the intercepted arc. Okay, so here as you can see there is a secant here and a tangent, and they intersect in a point of tangency. So this is the point of tangency, point of tangency. Okay, so based on the theorem, the measure angle form is 1/2 the measure of its intercepted arc. Okay, so we have here two angle. We have angle, sorry, can have a, okay. So we have, there are two angle that is formed, that are formed. We have angle AYB, AYB, and angle AYC. We have angle AYC. So there are two angle. So how do we find the measurement of the two angle? So using their intercepted arc, we can find their measurement. So what? So let's start with angle AYB is equal to, based on the theorem, 1/2 of the measure of its intercepted arc. So we have 1/2. What is the intercepted arc? We have AYC, AYV. So the intercepted arc is what? Arc AY. So we have arc AY. Measurement of arc AY. Okay, so let's have a given first. Okay, so the given is measurement of arc AB is equal to 170, and the measurement of arc AY is equal to 190. So let's assign on the figure so that you can visualize where is it. So we have AY, we have 190 degrees, and the line AB, I know, arc AB, no, arc AB, no, that will be arc ARY. So that will be ARY. So ARY. So this will be 170 degrees. Okay, so using the theorem, so let us find now the values of, or the measurement of angle AYB. So we have measurement of angle AYB is equal to, let us substitute. So we have 1/2. What is AY? The intercepted of AYB is the arc AY. So the AY is 190 degrees is equal to, so 190 multiplied by 1, that is still 190 divided by 2. So the answer will be 95 degrees. So that will be the measurement of angle AYB. It's 95 degrees. Next one, we have the measurement of angle AYC is equal to 1/2 its intercepted arc. The intercepted arc of AYC is arc ARY. So we have ARY measurement. Okay, so we have 1/2. What is the A measurement of ARY? Arc ARY is 170. So we have 170 multiplied by 1/2. So 170 multiplied by 1 divided by 2. That will be 85 degrees. So that will be the measurement of this angle. Okay, can you follow? So remember those theorem.
For more videos on mathematics, please don't forget to subscribe.